Welcome to the Neutral Podcast, where we discuss paving the way to a sustainable tomorrow. I'm Nate Helbach, your host, founder, and CEO of the Neutral Project, a sustainable real estate development company. Join us each week as we host world-renowned guests and explore dynamic landscapes of real estate development, alternative investing, sustainability, forestry, urbanism, and new cutting-edge carbon-neutral construction materials that are shaping the cities of tomorrow. Welcome back to the Neutral Podcast. Thanks for joining us today. Today we have a special guest from one of our partners, Asta Fivgas, who works for RWW, Reflections Window Wall. And they are in the process right now of designing and will start building our Passive House rated facade at the Edison, which is the 32-story mass timber project in downtown Milwaukee. And one of the big feats that they are tackling is how to design a glass facade that meets Passive House criteria, which for those who know Passive House is no easy challenge. So today we're going to talk a little bit about the Edison and then dive into the sustainability features of our facade and how RWW is designing the facade to meet Passive House criteria. So Asta is going to walk us through it, which I'm excited for. And maybe, Asta, just to kick us off, if you could give us a little bit of background on yourself and RWW.
Sure. Hi, everyone. My name is Asta Fivgas. I am the Director of Preconstruction at Reflection Window and Wall. I've been with Reflection for, I'm going to say, going on 7 years at this point. My background's in architecture. I'm a registered architect in the state of New York. And design-wise, I started in, high-end design, moving into more technical architecture, worked at Thornton Tomasetti for a time before joining Reflection on the construction side, learning more about technical aspects of new facades and high-performing facades, as well as a lot of our sustainability. So thank you for having me. And a little quick intro on Reflection Window and Wall. We are a glass and metal facades company. We were started in 2001, based in Chicago, and we work all over the U.S. with multiple supply chains that I will be talking about shortly.
Awesome. Let's dive into your presentation. Ooh. And then we can talk a little bit more about the Edison once we're done.
Sounds good. Let me know when you guys can see my screen.
We can see it. And for those that are listening in on Spotify or Apple Podcast, I would recommend head over to YouTube to review the presentation either now or when you're done watching this.
It'll make a lot more sense if you can see some of these visuals for sure. Okay, so I'll just start us off real quick. We're talking a little bit about Reflections. We are headquartered in Chicago. I'm personally based in New York. My team kind of travels all over the U.S., so we're wherever we need to be. Like I mentioned, we have glass and metal facades, so it's focused mainly on window wall and curtain wall products. We have our own proprietary systems, as well as a new punch window that we just released. In terms of where we fabricate, we have 3 non-domestic fabrication partners that we work with and have worked with for many years at this point, as well as a domestic solution. Domestically, we're in Indianapolis. We tend to run kind of smaller stuff out of that shop. But our non-domestic supply chain partners, and find that's important for what we're talking about today in terms of the Edison project and the facade we're developing there, is we kind of talk about some of the strategies for sustainability coming through them. So we work with a company outside Shanghai. We have another fabricator outside Mumbai in India, and another outside, well, not outside, but in Doha, Qatar. So this is just a quick slide kind of showing some of those points. And some of the cities we've worked in definitely need to add Edison on this one. To the next slide. So high level, one of the things with the Edison and a big part of this project, knowing is Passive House, is that we wanted to try and focus on what are ways that we could implement some of the sustainability initiatives that we're passionate about and that are very important to our company and to the building community in this project. Because A, the Neutral Project is also extremely interested in these things. It's important to them for this job. And B, it's just, highly visible. So it's an opportunity to kind of get the public more aware of what's going on. So the first thing I want to talk about was carbon dioxide and aluminum. The building industry, we're all trying to do what we can to improve upon, the atmosphere, the earth, keeping us here longer, keeping us healthier longer. And a big pollutant would be carbon dioxide emissions. And a lot of that does come from, well, not a lot of it, but there's a good portion that comes from the building industry. So the production of aluminum creates carbon dioxide that releases into the environment. And the general global range right now is about 14 to 27 kilograms of carbon dioxide for every 1 kilogram of aluminum extrusion produced. So when we talk about buildings that have glass and metal facades, aluminum and glass facades, you can imagine that's just a tremendous amount of carbon dioxide that's being released. So one strategy that we've worked very hard on at Reflection that I'm very proud of and that we are trending towards across all of the new projects that we're working on is looking at low embodied carbon. So, a sustainable future requires that we get creative about the ways to minimize. So what low embodied carbon aluminum is that it utilizes supply chains that are able to support their production by way of renewable energy. So renewable as in solar energy, renewable as in hydro-powered plants. And if we're at an initial rate of 14 to 27 kilograms per 1 kilogram of aluminum, that can be reduced down to 2.6 to 4 kilograms per one. And that's an 80% plus improvement depending on who you're working with and who you're supplying from. So when we started talking to Neutral Project about this job, that was a big point that we were really excited to kind of commit to exploring and trying to utilize on this job.
And one thing that I want to just point out quickly for those that are listening is that we're not reducing the amount of energy or embodied carbon required to make aluminum, but instead we're just replacing the source of that energy. So instead of getting it from like coal power plants, we're getting it from solar and hydro powered plants. So we don't have the magic cure for figuring out how to make aluminum with way less carbon and way less energy. It's just basically replacing and substituting some of the energy sources.
Correct. Yeah. So it's focusing on partners who are able to provide more sustainably minded energy sources for their production. That's 100% correct. And, we don't really stop at just, low embodied carbon aluminum for this job. We also are working with partners who across the board in other aspects of, assembly, sealant, paint, all of those different areas where the unitization is affected, who is able to do that with solar powered plants. And luckily via our, both Mumbai and Qatar, I think we're more focused on Mumbai for this project at this point. Dow just certified one of our partners for the low embodied, I think it's carbon neutral sealant. So we're able to utilize that on this job. So it's not just the aluminum production itself, but what are the other aspects of the project that can be more sustainable and where we can be more sustainability minded. Moving on quickly to this next point, just kind of talking about performance goals of the project's facade. So as Nate mentioned, this is a passive house project. So there's a tremendous amount of goals across the board for all scopes. Regarding ours, it's the idea of a high performing facade. So Reflection's able to assist with a lot of energy modeling. We've been working with the project team to kind of review and model different selections, different ideas, figure out how it impacts the job on both micro and macro levels and how it contributes to the overall building. So perhaps if something in the facade moves a little higher, it can offset something in the HVAC and vice versa. The project also required triple glazed units instead of regular IGUs. There was an increase in the project on opaque versus vision area to improve the R value of the building. The goal for this project for vision was a U value of 0.24, which is lower than typical code, which that converts to an R value of 4.17. Additionally, for the TGUs, elements for performance, there's a requirement for warm edge spacers, argon infill, some of the more typical things, but applied to the triple glazed. And then also looking at triple silver low E as the baseline for the low E product.
And Asta, the TGU stands for triple glazed unit.
Yeah.
And so for the TGU, we're looking at those higher quantities for specifically Passive House, correct?
Correct.
Okay.
Yeah, I mean, there's other projects that demand a triple glazed unit. Sometimes it's for sound insulative values. You can at times get better OITC or STC performance with a triple glaze. But in this case, it was geared towards the sustainability of the Passive House requirement. And that's a nice little render from an early phase of Edison. So let's talk about low E. So right now on the screen, I'm showing a comparison between two low E products. One a Solar Band 67 and one a Solar Band 72. Solar Band 67 is a double silver, but you can see that, and then Solar Band 72 is a triple silver. And in the chart, you can see that both the U factors in the winter and the summer are the same, but you start to see differences in the VLT, which is your visible light transmittance, and I'll have some slides to explain that later. Your SHGC, you start to get slightly better performance with Solar Band 72, and then your exterior reflectance and your interior reflectance. And you can think of those as, I like to think of it kind of as like the mirror effect of the glass, like how much of like you can you see in the glass when you look at it, both from the exterior and the interior. So when we just look strictly at visible light transmittance, this is usually expressed in 0 to 1 ratio, or in this case, 0 to 100. That would be like 0.53, 0.68. And that's the amount of visible light that you're able to kind of see through the glass. And you'll notice that on the triple silver, it has slightly better performance, but it also has better visible light transmittance, which from an occupant standpoint is more attractive. So that was a requirement of the project that also had a benefit as well. And then thinking about the U factors and SHGCs, so since most people don't use these terms every day, the U factor is basically how well it insulates. So what you want is a lower number here. So 0.3, 0.25, 0.24, like you're improving on the insulated value. SHGC is your solar heat gain coefficient. And basically, for our purposes, we also want a lower number here, which means that we're not taking on additional heat. If you have a higher number, it means that it's really good at solar heat collection and not something that we wanted for the performance of the facade in terms of the Edison. So that kind of explained those two. Again, thinking more about low E's, we also explored with Edison the idea of using one low E versus two coated low E surfaces. And the TGU makeup on Edison, these are all millimeters. So it's an 8, 12, 6, 12, 6, both of the 12s being about ½ inch, both with argon infill. And I'm sharing some modeling data for some of the units within our window wall system, talking about what's the performance if we only use a triple silver on surface number 2 versus what's the performance if we use SKN 044, it's a Saint-Gobain coating, on surfaces number 2 and number 4. And you can see there's a minimal improvement when you move from one triple silver to 2 low E coatings. But when we kind of talked about earlier, the idea of visible light transmittance, though you get a small improvement on U value, you have to kind of think about the percentage of visible light. So for this Solar Band 72 product, the VLT was around, I want to say back here, 68. So when we look at this chart, you're kind of in between here, which is pretty clear. It's a pretty good vision for the job. When you're looking at two stacked low E's, these are the SKN product is a 48-49 on the VLT scale. So think about looking through 2 of these that are stacked on top of each other, which will probably be closer to a 40-35-40. So there's a dramatic change on the occupant experience with the higher performance. And that's something that we've been working a lot with the design team to weigh against each other. How much do we need for performance? How much of an impact will it have for the occupant? I think it's something that you don't really think about a lot. Like sometimes we get hyper-focused on the facade just needs to meet these performance goals and look nice from a distance. But when you're standing outside or looking out over the city at night and everything's like really dark because your glass has so many low E coatings and the VLT isn't very high, that's a sensory kind of experience that might not be appropriate for the job. Little video that kind of shows the thermal performing portion of the facade versus the air tightness. So the system on Edison, it's a window wall system. It's our RWW 9500 series. It's a flush wall window wall. So I'll zoom into this detail, which is a little pixelated, meaning that the window wall itself cantilevers over the slab edge so that it can pick up a flush slab cover. So this is just kind of like an easy detail of that. And with that being said, the idea of a window wall performance, you're not like a curtain wall where you have fire stopping and you kind of have a unit that encapsulates the facade edge. The facade ends up being a rain screen system. So this is just kind of showing the facade components, and then it's going to show you both the thermal and the air tightness of the facade. That's our head receptor. That was solar receptor. You see the insulation. So this is the water line in blue and the air line in yellow. And then this is kind of a thermal performance to see, we've got a lot of special thermal breaks and stuff in the system to help control that. Thinking about, air tightness, one important thing is that when you get air changes through air leakage within the system, you end up losing the heat coolant side. So even though we're really focused on making sure the TGU has really high performance, we've got a good U value. We're thinking about like how it's going to perform in the summer, how it's going to perform in the winter, how it's going to help the HVAC. You don't have air tightness, you're just going to have a tremendous amount of air leakage, and it kind of negates some of those moves. So changes through air leakage within the system, you end up losing the heat cool inside the building through the air changing itself. So no matter how high your R value, which is the inversion of your U value is, you don't have air tightness, you're counteracting those moves. So now we've kind of like talked about some of the terms and the important aspects. One thing I did want to go into is, the system we provided and things that we did above and beyond our baseline system for this job to help meet standards. I already talked about the ongoing work with the team to, model everything in real time so that we could make good decisions that were building on each other. But additionally, we were trying to maximize the vision glazing since, opaque has better performance than vision, but you can't just have one building that's all spandrel glass. Like you need some sort of vision area. So for that, it's trying to maximize the vision within the stringent performance requirements, modeling these strategies to set on the best performance and aesthetic value. And additionally, the mass timber building. So there's the added component of coordination to accommodate the increased deflection requirements and how it connects back to the facade. The facade connects back to the structural system with that. So there were some moves and adjustments that we made to our base system to meet aesthetics and to meet just the structural performance. And then design strategy using the one surface low versus the two surface. I think at this point, we're focused on the Solar Band 72 for the job. So it's one surface with better visibility. Maximizing the amount of insulation at the flab edge. So what that means is this area here is an insulation, and this is just a standard detail. So basically you're looking at 1 inch of insulation. This is like a 2-inch space. So it was how do we get more insulation stuffed in this cavity so that there's better performance here. Additionally, some moves on the job that I don't have a detail of are interior, like furred walls on the interior of the building. So on the back side of the window wall, there was a lot of coordination with other trades who would be putting in stud walls, putting in insulation, coordinating what the condensation would be there, making sure that everything was performing correctly, because with the window wall system, the back of the system is basically your air barrier. So having all the insulation inboard, what was the impact? And then for the opaque areas, we designed custom thermal breaks for the project with new adapters for the system infills, including the metal panels. And a note on that, just for thermal in general, aluminum is 3 times as conductive as steel. However much insulation you have in the metal of the panel ends up being short-circuited by the aluminum. So you need to tackle the conduction you're getting through the mullions themselves, which is generally handled with non-thermally conductive product. So these little guys here, which are a little hard to see, they're thermal breaks, and the product that we use, the best one to look at, we typically use a polyamide fiberglass extrusion. So those are just a couple of the moves on this job that we made.
Can you explain for the audience what a thermal break is for those maybe who aren't super familiar with technical terms?
Yeah, I mean, I think the easiest way to think about a thermal break is I think the video may have had like a good, let's see here. When you kind of look at this thermal view right now, yellow is hotter, this is cooler. I think this is about like 50, 60 degrees in the modeling scale. When you look at this is your thermal break. So it's basically disconnecting two aluminum pieces from each other and preventing the cool or the hot bridging through them. So you still get the performance of both of your aluminum elements, but you're stopping them at a certain point. So you can see it actually happening right here.
And the reason why we're concerned about thermal breaks is because those are the areas that the exterior directly connects to basically the interior of the building. Whereas in the middle here, like the slab edge, you have insulation and an air cavity where you don't have a lot of that thermal transfer coming in.
Correct. Exactly right. See, no layman's terms. You are expert on thermal bridging.
Definitely not an expert.
Yeah, that is kind of what I prepped for this.
Cool. One of the other questions I had, which has been a big kind of point of conversation with the design team, is nobody wants to feel like they're walking into this like dark room when they walk into a unit.
Yeah.
And so that's something that we've been talking about a lot with the VLT ratio that you discussed. And it sounds like we're kind of in the range of very light, actually, not in being super dark, which is great to hear that we solved that problem.
Yeah, I think whenever, I briefly showed a slide. It was a thermal report comparing the 72, which is the one coating, to the double coating, the two SKN 044s. And I think the performance was within like 0.05 on the majority of them, which when you weigh it out against occupant comfort, it like wasn't enough of a move to feel like we'll have it be a little dark because we're getting like this huge performance boost somewhere else. So yeah, I think it's gonna be really nice. And it also had pretty low reflectance both on the interior and exterior. So if you're standing in your unit at night, you're gonna be able to look out over the city. You're not gonna be looking at yourself, which is always a bonus.
Yeah. I hate that when you look into a window and you see yourself like reflected. Yeah, that's the worst. The other question I had for you is, because it's a window wall system, which for those who don't know, most developers either go with window wall, a punched opening, or a curtain wall. And all that means is basically a punched opening is you build out a wall and you put a window on it. Window wall there's basically just a big window on the deck, and then curtain wall is actually like structural, so it hangs off of the building. But because we picked a window wall system, what are the maybe like implications for install that are more challenging versus doing like, for example, a curtain wall system?
Yeah, I mean, I think that, so the way that the reflection systems work, and again, like this is like kind of specific to like our product. There's lots of different ways to install different products, and all of them have, pros and cons. But for both our curtain wall and our window wall, our goal is to install everything from the deck, unless, of course, it's inaccessible, it's a shear wall or that type of condition. So I think some of the bonuses of curtain wall is typically you're dealing with embeds, cast in place anchor systems. So you're handing those over to your structural sub early on, they're getting them in, and then when our crew is getting on site, they're focused on setting panels. Everything's been checked. With a window wall system, you tend to be on more floors at once, which, good or bad, you tend to be a little closer to, this is a mass timber job. So in traditional concrete, you'd be a little closer to the concrete sub ahead of you. In mass timber, it'll probably be a little different, but you're spread out over more floors. So we tend to run the crews kind of in a snake. So we've got layout crew, silk crew, head crew, perimeter sealant crew. Then you're putting on any of your slab covers and tipping in panels. And once you tip in the panel, you're putting a drive on and you're closing the floor in terms of a performance aspect. Our curtain wall, our anchor is attached to our embed. So you're just setting the panel. So that's kind of a difference between them. I don't think it's really one's better or worse than the other. They're both pretty quick in terms of install. It's just more guys on the floor.
Yeah, I would disagree. I would say window wall is actually a lot better than curtain wall. And the reason being, we did a big analysis when we started Edison because there's so much glass on the facade of looking at what one do we go with, a window wall or curtain wall. And the two big items for us were, one is schedule, which is always a big point of contention for everyone. But the reason we didn't like curtain wall for schedule is because it's a relatively tight site and we only have one tower crane. And so the amount of time we spend putting up the curtain wall, we would basically be using that tower crane full time. And so our goal is always to start timber and then shortly thereafter come with facade to get things closed up relatively quickly. Because the faster we close the facade, the faster we get things airtight, the faster we can turn interiors, the faster we finish the building. And so the factor was really just crane time of like, how long can we take to both do the mass timber erection, but at the same time do curtain wall. And the equation didn't work. It was like, we have to finish mass timber and then start curtain wall, which wasn't great. And so the window wall, because we can tip those up from the interior and use the skip hoists and other methods of getting the window wall up to that floor, we're now able to keep the mass timber crew going with the tower crane on mass timber erection and then concurrently come in and do window wall and just do tilt up window walls like your guys' system has. So that's been like, I actually think a really big key of why we really like the system you guys are proposing for Edison.
Yeah. I mean, it definitely, like there's so many, like you said, there's so many factors when you're trying to figure out what your facade should be. Performance is a factor, aesthetic is a factor, schedule is a factor, cost is a factor, all of those things. And I think that, like from where I'm sitting, one of the really nice things is I don't have to argue for window wall or curtain wall because we can do both. So like we're happy to provide both, but I agree with you. For Edison, it is very tight. Logistically, it's a little bit of a challenge. So having everything on the interior and not having to touch the tower crane is always a bonus.
Yeah. Well, really, really appreciate you coming on and talking to us about these details. It's always fun to get into the weeds on the passive house and the facade detailing. So I appreciate that. If we have any of our audience wanting to find you or Reflections Window Wall, where would they find you?
They can find us at www.reflectionwindow.com. And you can find me on LinkedIn, Asta Fivgas. Feel free to reach out and I'm happy to chat all things facade, sustainability, technical architecture.
Awesome. Thanks for joining us.
Cool. Thank you.
At the Neutral Project, we're not just building structures. We're building a legacy of sustainability, helping align your investments with a sustainable future. We'd like to thank you for being part of this conversation. For more information and to stay up to date on how we're reshaping the future through environmentally conscious development, visit our social media accounts or our website at theneutralproject.com. Thanks again for tuning in, and we'll see you next time on the Neutral Podcast.